Hello and welcome to the final video of Intro Chem for this weird semester. We're going to go over the answer key to Tuesday, April 28th. And in this video, we're going to look at electron affinity. Now, in our previous video, we talked about ionization energy. Ionization energy is the energy it takes to subtract an electron. It's endothermic in that you need to put energy in. Electron affinity is the exact opposite. It's the energy that is released when you get an electron. And the trends for this are not as clear, but there are some trends. First, let's take a look at our group 1 metals. As we move up the periodic table in our group 1 metals, our electron affinity is more negative. That means we want the electron more. So hydrogen wants an electron more than rubidium. Now for our group 2 metals, they're all roughly 0, but it moves down. It becomes more favorable as you move down the periodic table. Beryllium and magnesium, you can see this greater than 0. That means they really never want an electron. Now for our nonmetals here, as we move left to right, we become more negative, except for nitrogen. So here in this third row of our nonmetals, we break the trend. So it goes up, up, down, up for the most part. And for our halogens, that's where it's going to be your most negative out of any group is your halogens. They want electrons the most. Your noble gases do not want an electron, so that's why they're all greater than 0. So our first question is just to look at these trends and try to find the molecule that is more negative or exothermic electron affinity. So sodium or rubidium. So group 1, so the things at the top of the group 1s are more negative, so that's sodium. Boron or sulfur. Sulfur is more to the right of boron, so it's going to be sulfur. Carbon or nitrogen. Well, nitrogen doesn't want an electron, so it's going to be carbon. Lithium or fluoride. Fluorides are halogen, so it wants it more. Magnesium or sulfur. Sulfur is a nonmetal, so it's going to want it more than magnesium, which doesn't want an electron at all. The last thing we're going to look at this semester is metallic characteristics of atoms. And basically on the periodic table, your bottom left is your most metallic, and your top right is your least. So that's how our trend. Bottom left is metallic, and as we move to the top right, we become less metallic. So we can separate metals into and nonmetals. And in between our metals and nonmetals, you see this black staircase. Basically, almost any element with the exclusion of aluminum and PO, any element that touches this black line is called a metalloid. That is, they have characteristics of a metal and they have characteristics of a non-metal as well. So they're like half and half. So our last question is just figuring out what is more metallic. So you're basically asking who's farther down and to the left. So SR versus SB. So SR is right here, while SB is all the way over to the right, so that's going to be SR. AS, which is right here, versus BI. Bismuth is further down than arsenic, so it's going to be BI. Sulfur or arsenic. Sulfur's right here, back and to the left, it's going to be arsenic. And tin or lead. So tin's right here. Lead is, or that's not tin, that's antimony. Antimony or lead. Lead is down and to the left of antimony, so lead's going to be more metallic. And that's it for these questions. If you have any questions whatsoever, please let me know. Otherwise, good luck on your final.